Our next speaker is Yizhar Toren. With almost 20 years experience working as a data scientist, Izzy is currently senior data scientist at Shopify. Please put your hands together, give a warm crunch welcome to Yizhar Toren.
Thank you. Can you hear me? Okay, great. Thank you very much. It's great to be back after such a long time in person. I was here at the last in-person conference, and it's really good to be back. Today I'm going to talk to you about how we learn from pilots at Shopify. As you can see, this is not necessarily going to be a very kind of corporate presentation. It's something very near and dear to my heart. I think when I started working on these slides a while ago, I was debating between maybe Lord of the Rings or another maybe magic-related franchise, all rights reserved, etc., etc. But with the last few months, with the good content coming out, I'm very happy I went with this team. So, what are we going to talk about today? I'm going to start by introducing myself and my employer. We're going to talk about two very, very different places that I hope some of you or all of you as data scientists have encountered. One of them, very nice place, a great place to be, a land of plenty, A/B testing. And another one, not so fun, and we'll talk exactly about why. After the fact analysis is not fun. And then, because I'm talking about pilots, and because pilots tend to be, I would say, more in the not so fun place, I'm going to talk to you about how with some practical magic, I call it, boots, a dice, and a little bit of cloning, you might be able to escape that horrible place and get very close to the very nice place we all want to be in terms of A/B testing. I'm going to go through the different methods. It's not going to be a tutorial about all these methods, just a kind of overview explanation, maybe to give you some gist about the intuition. Feel free to reach out to me after that if you want to dive into the technical details, which I always love to do. And at the end, I'm going to leave you with some takeaway messages, how to communicate to stakeholders, and things you should consider and take along the way with you for your next exploration into pilot data. And we'll have some time for questions at the end. I'll try and keep it short so we can get to lunch all happy and satisfied. So, a few words about myself. Well, the Hebrew name, I want to say, even Israelis mispronounce my name, so I always go by Izzy. It's easier to remember. 20 years experience as a data scientist. I started right off university in the fintech industry and biotech industry, worked in gaming, currently e-commerce, and also other places as well, working a lot with experimentation, clinical studies, A/B testing, whatever you want to call it. So I've been working a lot on this topic in many different domains. When I say Bayesian, it means usually that I like solving problems with very sophisticated mathematical methods. But with that in mind, I also realized that, as a data scientist, you work in a team, you work in a context, and sometimes the best answer you can give is just a simple average to get things going. And I know we all want to build the latest and greatest, reinforcement learning, contextual bandit, whatever, latest and greatest neural network. But sometimes, you just want to get shit done. Sorry for the language. And it's important to remember that. And yeah, if you want to talk to me about how terrible your WOD was or how much you ate assault bikes, I'm your guy. Officially, from the last 2022 Open, I'm a mediocre CrossFitter. I think it was like 53rd percentile, so it's like I really have the stamp for that. Okay, and let's get started. And I want to talk to you about a wonderful place. We all want to live there. And it's the wonderful shores of A/B testing land. It is a great place where data is plentiful, and you don't just have a lot of data, it's high quality data. We all want to have that, right? It's also a place where it's very easy to pick a feature or a financial plan or whatever it is you're working on and randomize on it, which is not always that trivial to do, right? Especially if you're going to complicated, interdependent production systems. But that's actually really easy to do. And because it's easy to do, it's also easy to automate a lot of things around it in terms of the randomization itself, data collection, data analysis. Once you have that set up in place, and I hope for all of you that you work in an organization that has that, maybe in-house, maybe as a part of the platform you're using, it's really easy to automate a lot of the things, including the analysis, to be honest, kind of calculating t-test or whatever method you want to use in order to make the comparison. Even very sophisticated stuff can be automated. And this is a great place to be in, right? This is where we all want to be. This is where we all should strive to be. A/B testing, and I will mention that a couple of times, are the right way to answer business questions for a lot of good reasons. We'll go through them kind of in a nutshell as I'm speaking. There are some problems. You also need to be aware of that. A/B testing land is not perfect. Even with the perfect setup, the perfect state of mind, the perfect stakeholder buy-in, the perfect platform and everything, there are some issues. A little bit of a shameless plug here. I hope you'll get the link later in the presentation. A talk I gave a couple of months ago. Things can go wrong even if everything is set up in a very, very good way. If you want, I can expand on it, maybe if we have a little bit of time later, or if reach out to me later if you want to talk a little bit more about why there can be problems. But at the end of the day, this is the place you want to be in, right? This is the place we should strive to be in. And let's talk about another place on the other side of the map. It's not fun. This is what I call after the fact, post-mortem. You can sometimes call it even post-mortem analysis, right? And this is a scenario I hope none of you encountered, but I assume most of you did. You join a new team. You're the data scientist. You're the data scientist, right? And you want to show your worth to the team, and you want to show your value. I didn't mention that in Shopify, we work pretty much 100% embedded with the team. So when you are the data scientist in the team, you are that one person that needs to be answering a lot of good questions. And your dev manager or your PM comes to you and say, we had a pilot a couple of months ago. We ran some tests, and we ran some experimentation maybe or something. What can you tell me about it? And you look at the data, and it's 50 customers, maybe randomized, probably not, opt-in. And usually the answer should be, I can't really do much. But it's really hard to give that answer sometimes because you want to show your value, you want to try and do something. But it's not a fun place to be. And unfortunately, to be honest, a lot of pilot data, a lot of pilots that you run live in that domain, in that place. And why? Because pilots, by design, are small, right? We don't want to release a new feature to maybe half of our customers. We want to test that things are working. So pilots will be small in scope, limited in time, usually not randomized. I mean, it doesn't make sense if you think about it. I want to opt in or onboard some of my good beta customers for a new feature for them to test. So I'm going to onboard, 200 of them. And then I'm going to say to 100, no, you're not getting it. That doesn't make a lot of sense, right? There is onboarding, there's maybe training even that has to come with a new feature. So randomizing doesn't make sense, and it's opt-in a lot of the time, which means, and I'll mention this again and again, you have opt-in bias. If the feature you're going to release at the very end is not going to be opt-in, it's going to be to everybody at the same time, and it's not going to be opt-in, but your pilot is opt-in, it immediately creates this skew for the type of customers that tend to opt-in. So I'm going to repeat that point later. So again, in general, pilots are geared to answer different questions, right? It's basically you want to see that if you put something in production, you're not really burning down the house. That's one thing pilots are actually designed to do. If it's something that involves money, if this feature is going to cost your company something in terms of resources, discounts or something else that requires more intensive resources, there is a limit to the cost that you're willing to put on a pilot, especially if it's only testing something. And also reputation. I think we all encountered these situations where even very large, very famous companies try to release a new feature to a small audience, and then everybody hears about it. It starts exploding on Hacker News, and everybody's complaining, why am I not in this, in the VIP list? What are you doing? Why aren't you giving this awesome thing to everybody? The reason is they didn't want to. They wanted to test. So you want to also limit the kind of reputational risk or the exposure. And then the question is, with this kind of data, can we do something more? Can we answer some interesting questions from it? I want to say, in order to escape this place, something has to give. If all you have in your hands is, again, a few dozen customers, non-randomized, you will not be able to do much. But under some circumstances, and some of them are even under your control as a data scientist, or at least you should have a say in them, you can try and escape this horrible place. And I'm going to talk about two situations where this can happen. One is if your pilot is actually not that small. And when I say not that small, I'm talking about maybe hundreds of customers, maybe thousands of customers. Let's say numbers that you feel comfortable starting doing statistics about. There are some limitations there, but I'll talk about that. And the other situation is if you can, and I'll explain later exactly what I mean by that, but if you can inject some kind of randomization that would make sense. But we'll get to that later. Let's talk about larger pilots. So I mentioned a pair of boots, a dice, and some cloning magic. Let's talk about the pair of boots. This is not very strong magic. or very strong statistical method, if you want to get technical here. Just by raise of hand, if you don't mind, how many are familiar with the term bootstrapping in general? Oh, good. Awesome. I don't know. I will explain very quickly. So the idea is that, let's say I have a pilot with 200 customers. So I can calculate something like conversion rate for those 200 customers in the pilot. That's a number, or maybe a set of numbers, but that's basically one number. What I'm going to do, I'm going to put all the 200 customers in a box and shake it, and then pull one customer, and then put it back. Just write it down, the customer that I pulled out. And then I'm going to shake the box again with all the 200 customers and pull another one, maybe the same one twice, or maybe 3 times or more. And then I'm going to do that, let's say, 100 times. That would be 50%. That would make sense. And then I get a resample of 100 customers, right? And then I'm going to calculate my KPI on that sample. And then I'm going to repeat that, shaking and sampling, maybe 1,000 times, 10,000 times. And what you get at the end, instead of one number, you get a distribution, right? So it's weak magic because you only work with the data you have. What it can give you is at least some indication how weird the numbers you got from your pilots are, how sensitive your pilot is to some small subset of customers that really skewed everything up. It's a general kind of analysis that's good to do even if you have a full and proper A/B test. Like I said, A/B tests are not perfect. And it gives you some idea, at least I want to say maybe as a tripwire, how weird the numbers you got, how sensitive they are to some weird sampling bias that you have in your pilot. It's a very good practice to do in any case, but it doesn't get you very far. Let's talk about getting further. So, like I said, I have 200 customers in my pilot. What if I could tell you that I can magically manifest digital twins? For each one of my customers, I'm going to create, out of thin air, a digital twin for that customer that's similar in a long list of different features that I have. Again, in Shopify, we deal with merchants, so maybe the same industry, the same territory, similar financial characteristics, maybe similar age. I'm going to try and match that as best as I can along a long list of features. So that digital twin is similar in every single way, except it wasn't in the pilot. So that starts sounding very close to something like an A/B test, right? In a sense of randomization, it's a nice way of trying to find that, what we call, in econometrics, you call it the counterfactual. What would have happened if that merchant was not in the pilot? You'd be surprised. Sometimes people actually do that manually. In econometrics, you have these cases where you look at countries, for example, and you look at some high-level metrics, and then you say, OK, I'm going to look at Belgium, for example. And Belgium implemented a new monetary policy last month. But before that, if I look at other countries around the world based on GDP and other KPIs that are important to me, Sweden is kind of similar to Belgium, but it didn't implement that monetary policy. You kind of do these manual matches, and people actually write very good studies. It's very hard work to find these twins. Assuming that you're working in an industry that has thousands, maybe hundreds of thousands of customers, so you have more data, you can use statistics to do that. And that is exactly what propensity scores are designed to do. Again, not a tutorial on propensity scores, but in a nutshell, and I hope I'm explaining it well, in a nutshell, the idea is that you look at the data in your pilot, you look at the rest of the population that was not in the pilot, and you try to rebalance both of these populations using weights, so they are similar on a lot of different measures that you have. That is the trick. And what you get out of it are 2 weighted samples, which is great because you can look at these weighted samples. They are weighted to be similar on a lot of different features. So if you calculate something like the difference between them, like average conversion or average monetary amounts or something like that, that will be meaningful to tell you, OK, your pilot changed conversion by, let's say, had an uplift of 1% or 5% difference in some KPI that you're trying to measure, response time or whatever. So that's great. You get an answer, which is better than not getting an answer, right? You're in a much better place, and you actually use not just your pilot data, but everything you know about the rest of your customers. There are some limits, though. It's an answer. Let's say it's not the absolute answer. This is not an A/B test. It's a good approximation. And why? So I'm going to get to the well, actually, I want to start with the fact that it's just not so easy to build these things. There are some methods that automate this, some machine learning methods as well. Like you can use some kind of out-of-the-box situations, but they can get very problematic, and I'll explain why. Second thing is that aggregated sums. It's a small thing, but when you talk to your stakeholders, they usually want to see real numbers, especially when it comes to money, and you can't really show them that because these are weighted sums. They don't behave exactly the same as real aggregation. And you still have the issue where maybe there are segments in your sample that are completely not represented. The good news, propensity scores will help you identify that. You can actually say, I'm going to keep, there is 10% of, let's say, customers outside the samples that are completely unrepresented in my sample, so I'm going to basically chop them off. Again, it's a limitation because they're not going to be part of your analysis, but also good because at least you will be able to inform the stakeholders that you're not going to cover 100%. So that's good. And last thing, and I think the most important point and why this is not as good as A/B test, is that you can only balance on what you see. So when we randomize, and this is, if you weren't aware of this, the really great thing about randomization is not just that you get two samples that are similar, right, in almost everything, and you get some guarantee. You can measure that. You should actually test that when you run an A/B test, if the two groups are actually similar or not. The good thing, the amazing thing about randomization is that it doesn't only work on things you can measure, it works on things that you can't measure. So in Shopify, for example, we know a lot about merchants. We don't know a lot about buyers, actually. This is kind of by design. And let's say you work for an optics shop. You're selling eyeglasses, spectacles. And the most important factor for the buyer to decide which pair to buy is the color of their eyes. That is something you will never have access to unless they actually tell you. So if someone's just browsing your website off the internet, you have no information about them, you will never know this piece of information. If you randomize, do a proper A/B test, there is some guarantee that you didn't oversample green-eyed people into your test group versus your control group. There is a guarantee. If you use propensity scores, you can only balance against what you see, and you might be actually balancing a little bit too hard in a way and end up with unbalanced or groups that are not very similar on something you can't measure, and then you get unintended consequences, and then when you actually put it in production, you don't get what you expect, and that's not a good place to be. So you need to be careful. So, like I said, this is for large pilots, and that's great, especially if you can get a lot of customers into your pilot, if this is not very expensive. What if you can't? Again, in Shopify, sometimes you run pilots on, 100, 200 shops. Not a very good number to start doing this kind of exercise with propensity scores, maybe, but maybe we can do something better. And it accounts for situations where you have some kind of hierarchy. So as I mentioned in Shopify, we have shops. Maybe I can recruit a few shops to my pilots, but these shops can have maybe hundreds, maybe thousands, maybe even more, tens of thousands of customers on a monthly basis. And maybe I can use that one to many relationship somehow in a smart way, especially if I can randomize on that. So again, in Shopify, it works really well for merchants and buyers, but you can think about players and logging sessions, maybe players and games, servers, API calls. I'm sure each one of you can give me an example that you can think about from your industry, what can be relevant there. And the idea is that we recruit merchants to the pilot. For example, this is an example we actually ran. Recruited merchants to the pilot and told them, listen, we're going to give you a new feature in your shop. Are you on board? Okay. But with merchant consent, we always get the merchant consent, and you have to in this situation. We're going to split your buyers 50-50 to the new experience and the old experience. You're going to get some support if you have trouble. Maybe you get some benefits or something. But the idea is that you onboard your merchants knowing that they're going to have some sort of test running on their shop. Everything is, of course, with consent. Maybe in different situations, if you're running servers and API calls, you don't even need to worry about this that much. You can actually do that. But if you have issues of consistency that you need to worry about, a little bit more complicated. But assuming you can do that, this is really powerful. So the way of thinking about this, if you need kind of a way to frame your thinking about this, I would say think about it as if you're running a whole lot of very small A/B tests. Each shop or each server or each player are their own little tiny A/B tests. Works very well when you have heterogeneity. So for example, in Shopify, we have very big merchants, tens of thousands of buyers every month, and then maybe very small merchants. So that A/B test might be not that reliable for them. But that works on those observational units. So what do we do with this? Think about it. We have all these nice results of tiny A/B tests. How do we combine them together? Just combining everything doesn't make sense. What you end up with is an A/B test that you ran on a non-representative sample. Not that great as a result. Someone asked me about like average of averages. Again, not a great idea. Why would you give a small shop that has a lot of noise attached to it, right? It's not a lot of measurements for a small shop, so whatever you're getting is very noisy. Why would you give it the same weight as a very large shop that should be very stable in terms of their KPI, so you can measure maybe more reliably there? Doesn't make a lot of sense. I'll talk about two ways that you can deal with kind of, that you can handle this kind of, or two ways that you want to go about doing these kind of combinations. One, post-certification. What is post-certification? Again, this is not a tutorial, I'm just trying to give you an intuition. So the idea is this, and if it sounds familiar to propensity scores, there's a good reason it is. Think about it this way. I look at my sample, and in my sample, I have something like 30% shops that are selling apparel, clothes, shoes, whatever. But when I look at the rest of the population, one not in a pilot, what I see is that actually in my population, there's actually closer to 50% of shops that are selling apparel. Okay, so, and I can look at other industries as well. And what I would like to do, and you can do it very simply with some weighting, I will overemphasize the importance of apparel shop in my pilot so that when I aggregate everything up, I'm using, again, weights here, they will contribute 50% to the average, right? Again, going back to weighted averages. So it's not very, you can even do it with pen and paper, right? And the idea is that you can take a distribution in your pilot, distribution outside your pilot, try to match them. And it's very similar to propensity score. The idea is now that your pilot is more representative of what would actually happen. Same thing happens if you see that there is a very niche category. Again, I don't want to discriminate against any people doing business, but let's say something like auto parts, maybe not the biggest categories in your portfolio, and maybe it's completely not represented in your sample, in your pilot data, and then you can say they are out of scope, which is also good to know, right? Also good to take into account. So you can do that, and then, but you tell me, okay, industry is great. I also want to control for geography. Okay, then I'm going to build a matrix, right, with a lot of cells in it. For industry and geography, state maybe, the cells start becoming smaller and smaller, especially when it comes to pilot data. Most of them will probably be empty. Rebalancing those becomes a little bit difficult, especially if you want to add another dimension and another dimension. It gets very complicated. And this is where I want to introduce you to MRP with the catchy name, multi-level regression and post-stratification. But don't worry, there's a cool acronym. They call it Mr. P. That's why I have a little Mr. P there. Again, I'm not going to go through all the details there. It's a very well-studied topic, very smart people building very smart methods and really good tools, especially in R, using Bayesian statistics. If you want to use this tool, go ahead and familiarize yourself with it. I'll be happy to chat a little bit about it later after the talk. But the idea is that this is a very powerful tool at your hand to take a sample and try and make it more representative for everything else. The origin of this method, if I believe I got it correctly, the origin of this method comes from the survey world. Again, think about the idea that people that answer surveys or answer, these voting polls might not represent the whole population, and you want to be able to take these results and adjust them so they actually represent what's going to happen. So that's where it comes from, so you can see the similarities. Okay, so far we talked about getting data from a pilot, trying to make it more representative of what's actually going to happen in order to give a good answer to the business question of what's going to happen. But maybe you have to dig deeper. Sometimes you want to dig deeper. Well, I want to say as data scientists, we always love to dig deep. But sometimes you actually have to. In some industries, just collecting data, running the pilot is a very expensive thing. Think about medical studies, again, starting in biotech, that was just running this small-scale study can be a very expensive thing, recruiting patients, not something that's easy to do. And if you are collecting a lot of data, you are expected to give a lot of answers from this data. And the question is, can you do more than just say, okay, we geared a pilot, we took the pilot, we ran it on 200 shops, we did some randomization on the buyer level, and we tested feature A versus feature B. Can you tell me more about something else about the products? I don't know, about the category, maybe about price, maybe about the time of the year, about something else. Can you dig a little bit deeper and get more insights out of it? So I like to think of it not as a one-time situation, but maybe as a workflow. Can you build a workflow that will take all the pilots that you have built so far, all the insights that you got, all the measurements that you made, maybe even from proper A/B tests that you ran. So for example, we're testing a feature A versus feature B, but a few months ago, we also ran something that had to do with price, like a little bit of a price test with some of our merchants. And we have some information about price. Can I take that knowledge and embed it into a model? So when I'm estimating the effect, not just of the feature I tested, but I also want to look at category, time of year, something else, I'm not just fitting on this weirdly, not unbalanced small sample, I'm also controlling for everything I already know before that. And then that should make my insights stronger in a way, right? And there are a lot of ways to do this. In classical statistics, you can kind of offset some parameters, hard code some parts of your model. In neural networks, there are some ideas around kind of embedding a neural network into another neural network as an input or just in the middle somehow. Not really sure how would you be able to control for the different effects there or measure them. With Bayesian statistics, as I said, I'm a Bayesian by belief at least, there are really great tools to do that. Multi-level from MRP, multi-level regression and that's the multi-level models. They allow you to take all the information you have from other areas, other domains, and plug them as priors into a Bayesian model. That's basically the idea. And with that, you can answer, or at least try to answer questions about more than just what you saw in the pilot, what you geared the pilot to measure. So I want to, again, qualify all of this. You need to be careful not to dig too deep here. Like I said, as data scientists, we love kind of sometimes torturing a small data set to death, right? And you need to be very careful with this. As I mentioned before, the pilot, for example, was geared to measure a feature. We have some good information about pricing. Okay, what can you tell me about pricing in a category? Maybe this was super significant in the model. It shows up, kind of, oh, there's a clear difference between category A and category B. Does that mean that they have different, maybe price elasticities or different interaction with the feature? I would be hesitant in saying yes based on this kind of sample data, right? This is not the full-scale study we need to do, but at least it can give you a clue, finding interesting findings, where do you want to ask the next questions, and also, in a sense, you can use that as tripwires. If in some categories, in some situations, some of your estimates don't make sense in a business sense, that would be at least a place you want to start asking more questions. So building these models takes time and effort. You need to be aware that you can get a lot of interesting insights from them, maybe not the answers you're looking for, but you can use those insights in order to ask more questions. And that's a very powerful thing, right? Because you don't just kind of test the waters and say, I think this is where you should go. You can back it up with numbers and information, which is very powerful inside an organization when you're trying to help, good decision making. One more mention. You can tell me, okay, we can't really randomize in my domain. We just can't. There are some methods that you can use before and after analysis. I'm not going to dive too deep into them in respect of time. I want to make sure that we can talk about talking to stakeholders and other things. I'll just mention they are weaker, they have their own problems. I'll be happy to talk about them later. But the idea is that you look at, instead of finding your digital clone somewhere else in the data, you find it in the past and try to estimate the future based on that. But if you want more information, come and talk to me later. Before we go to the conclusions, just two more things. One, about the dangers out there. I want to iterate selection bias, and opt-in bias again and again. Remember that, especially if what you're working on is going to be released without an opt-in. That always skews the result, and maybe look at how historical pilots performed compared to what actually happened as a way of gauging a worst-case scenario. Sample bias, I mentioned. Again, rare events, the same idea where if you're working on fraud, for example, maybe your samples are not very representative. And not to forget, I want to say an honorable mention, maybe not so honorable, engineering tests can really screw up a lot of your pilot data. Remember, this is geared up to test that you're not burning down production, and engineering tests will sometimes run while your pilot is running. Your engineers will, for example, log into the website and try to see if features are working, especially if you're looking at smaller units with randomization. It can kind of screw up the results, so remember that. They always say in a good consulting presentation, you should have these graphs, right? Two axes, you can put things on an axis, so I try to do that. When you talk to your stakeholders, you will often see these situations where you try to tell them, well, we couldn't randomize, so we ran propensity scores, and very quickly you see this kind of blank look of like, what? Okay, what are you talking about? So it's very important when you talk to stakeholders to kind of stay on message. You are trying to sell them something. The idea is that you need to send a message that the right thing to do is to A/B test. However, if you cannot do that, this becomes a trade-off. You can spend the effort on running an A/B test, but if you can't do that, you will have to spend more effort on data science resources. It's time, computational resources, skills, people, all of that, something that your stakeholders need to account for. And if I put it kind of on the graph, again, hybrid models, MRP, can get you very close to what you would get from an A/B test if they're done correctly, and at least will give you a warning when you're pretty far away. Propensity scores a little bit weaker. There's no randomization. You're kind of trying to build that randomization somehow with all the caveats I mentioned. Bayesian time series and causal impact, a lot of effort. I would say not great signal-to-noise ratio in a lot of cases, so it's a lot of effort to build, but maybe you might not get the results you want, and I'm not going to even talk about the other ones. So, as conclusion, what kind of can you take with you? First and foremost, try and have a say beforehand, right? If you're coming to a done deal, that's not a good place to be in. Try and have a say. You are a data scientist. You should have a stake at the table, right? In the way that pilots are designed and the pilots are ran, you should have a say, and you should try and negotiate. Can you do some kind of randomization? Okay, that's great. Let's think about how we do it and how we analyze the results later. Okay, if you can't, can you negotiate a larger pilot? You know, if it's a budget, maybe sometimes just, okay, instead of 200, let's do 2,000. It's more money, but we'll at least be able to get more answers, right, out of what we're doing. Remember the limits, like I said, opt-in again and again. It's always this problematic thing, but all the other caveats I mentioned, and make sure that you communicate it well to your stakeholders. Sometimes you will say, okay, 80% of customers are in, but the top 20% that actually generate most of the revenues are out, so we need to be very wary about deploying that to them. Maybe that will help you prioritize deployment. If possible, use a proper A/B test. Always push for that. Remember, that's where you want to live. And as a final note, I would say sometimes as data scientists, we get to be the bad guys, right? And when you're faced with, again, no small pilot, no randomization, sometimes you just have to say no if you want to be responsible team member, right, to drive good data-driven decisions. So sometimes you just have to say no. And with that, I want to thank you, and it's question time.
Thank you very much, Izzy, for that talk. It was magical.
Thank you.
And largely the audience is speechless because we only have a couple of questions so far. But audience, get your questions in if you would like Izzy to answer them. We have 10 minutes for Q&A, so let's use those minutes. And Izzy, looking at the first one, what could be the role of AI in all this? Now, what do you think?
Ooh, we're getting into into a hot debate here. I come from a very kind of, I want to say, a strict tradition, of statistics and mathematics. I will say this. The context is everything here. So there are two very strong cases for using AI in these kind of situations. One thing, if you have tabular data and you want to build something like propensity scores, you want to control for the features, you want to understand what you're building, I would not use AI, neural networks, or any kind of non-parametric AI or boosted methods or GBM or whatever. Maybe would not use that, even if it gives me a little bit of a better result, because I want to be able to understand the marginal effects in a very good way, especially because I don't see everything. However, if I have data like images, anything that's not tabular data, I would say that's the only way to go. You can think of these tiered approaches where you generate more tabular features from images or from this stream of data that you have, or the time series that you have. You can kind of think about it as a very good way of kind of pivoting your data into tabular data and then building some simpler models on top of that. But again, there is a role. What I would do most of the time, I would use AI at least as a benchmark, again, as a tripwire or as a benchmark. If I'm building something like, again, some kind of a causal model, and I'm using something as simple as a GLM, again, it's a Bayesian version of logistic regression with hierarchy and all kinds of complicated stuff, but I would also run some kind of a random forest, GBM, or again, if it's more complicated data structures, maybe again, some kind of a neural network on that data just to see how far am I from something that maybe would be able to predict a little bit better. So what's the trade-off that I'm getting for the ability to look inside to the internals of the model, right? So again, AI, I would say, has a role in this, maybe more as a benchmark, and also for cases where you don't have tabular data and then you kind of have to use it, right? If you're using images, you can use embeddings, but then again, you have to use something.
Great. Our next question, what tool do you use to conduct your pilot tests?
Shopify has a homespun platform. It's a mixture of, again, tools that allows developers to randomize things very easily with feature flags and feature flags that are built into the production. So Shopify has their own internal solution to do that. But I think, again, depending on which platform you integrate with, there are different tools that it will allow you to do it. So that's kind of for the execution part, for basically assigning merchants or customers, whatever you're working with, into the pilot, into the new feature. At the back end of it, we have a lot of good automation for A/B tests. But if not, then everything just go into the data warehouse, and from there, we pick it up.
Awesome. Our next question, how do you deal with the peaking problem in A/B tests?
Okay, interesting question. With A/B testing, so there are methods that are maybe less sensitive or more agnostic to peaking, at least in the statistical term. So I would say this. Bayesian statistics should be at least less agnostic to peaking before time, because if you look at the type of errors that you look in for Bayesian statistics, they're slightly different from the type 1, type 2 things you usually look for in a classical test, right? Which, if you peak in an A/B test that calculates p-values or something like that, and you're peaking beforehand, and you use that to make a decision, that's really bad. That kind of ruins the whole thing. Bayesian tests are less problematic. Not completely unproblematic, but you can kind of do that. There are also approaches which we use sometimes, especially if this is like a kind of time sensitive, if there's a benefit to making a decision fast versus just waiting for the pilot to conclude. There are some kind of serial analysis methods. I'm trying to remember the name, sequential probability ratio test. I think that's the name. For those of you who want to know, I can look it up later and try and give you the name. But basically, there are tests that have this idea that you start with a very big area of I just don't know. And that area gets smaller and smaller over time. And if at some point you cross one of the borderlines, you just say, OK, at this point, I was able to make a decision and say that there is a difference, there is no difference. So there are methods even to do that.
OK, awesome. Can a simple before-after comparison work if the pilot is run on a large data set with very little test as an alternative? Management doesn't like hearing no.
Yeah, I agree. So going back to, can you go back to the slides for a second? So talking about this kind of before-after analysis. Just before and after, if you're so lucky that you have this super stable data, and you want to sign your reputation on the fact that it's super stable, and you want to be careful with that. That is an option. What usually you want to try and do, as I said, is try and use the past as a precursor to the future. In econometrics, people would actually, again, find that digital twin. You look at GDP for two countries over time and say it was super correlated, and then one country did something and it became uncorrelated. People actually do that work, find these correlated time series, and use that to do like, OK, what happens after the change is the difference, right? That's kind of a before-after using this magical twin time series that you can find. It's really hard to do that. So what you do, you basically look at, again, finding that twin in the past, meaning that you look at historical data. You use some very heavy Bayesian machinery in order to build a very good model that historically was very, very well fitted to what you're trying to measure. And then you say, I'm going to take that model, which I trust a lot, and I'm going to roll it into the future. And that simulation will be my counterfactual. That's the idea of causal impact, in a nutshell. The problem there, these models are hard to build, I would say. It's also, if you know of a good extension of this approach to kind of this multivariate situation, this is usually like kind of one time series at a time. So this is one customer. So it has to be one customer that has a lot of activity. Not a lot of activity, that becomes a problem. And even with that, again, signal-to-noise ratio is usually not great. It's very hard to kind of, most of the time, you end up saying, I don't know, which is not a great answer, right? So that would be the problem with these kind of before-after methods. You have to at least use a method that will at least keep you from saying, oh, there's a difference. You have to use a method that will at least allow you to say, in a good way, I don't know. So that would be my point here.
Great. We have time for one more question, and I'd like to give the speaker the chance to select that question. So which one do you like the most, or which one would you like to answer?
Interesting. I'll talk about the second one, maybe. So how to say that the experiment is wrong? This is all about communication and setting expectations, right? This is the key here. Like I said, Shopify were embedded, so I know my PM very well, and the engineering team very well, and it has to be part of the stake here, right? People understand risks, and this is something that you need to communicate. When I was showing the trade-off before, if at the end of the day all you can do is something like weak propensity scores, you don't have a lot of data, you don't know a lot about what you're trying to rebalance, it's something that you need to communicate. Again, talking about before-after, you need to make sure that your stakeholders accept an I don't know. You need to be comfortable with saying I don't know sometimes. Again, data scientist can be a hard job, at least in that term. So I would say I've seen many cases, and I think we had that experience lately. Again, the feature I was working on, one of the ideas was, it was a new team I joined, we actually had some time, they were working on solving other problems, and the PM asked me, yeah, I'm willing to give you that budget of time and effort, instead of working on some reporting problems, take historical data and try and give me an understanding if, based on some historical data, without even a pilot, just historical data, this feature or something close to that can actually increase conversion. And yeah, at the end of the day, the answer was, to be honest, we can't really say. And that's something you have to make sure that your PM and your stakeholders are willing to hear.
Thank you so much. Big round of applause for Izzy, everybody.
Thank you very much.